Explorers sending back alarming data to Earth. The Explorer 1, NASA's farthest voyaged shuttle, continues to explore uncovered regions of the universe almost 50 years after its launch. Researchers are confused by the alarming data this famous spacecraft system is sending back to Earth. State-of-the-art technology seems to be breaking down. Join us as we discuss the curious records that the Explorer has been transmitting back to Earth during its space exploration journey. Researchers have been connected to state-of-the-art data since the Big Bang and were thrilled by the launch of Explorer 1 and Explorer 2 among various missions. Explorer 2 was the first shuttle to launch, departing from NASA Kennedy Space Center on August 21, 1977. On September 5th of that same year, Explorer 1 was launched 2 weeks later. However, they switched areas as twins. The weight of both spacecrafts is 720 pounds, roughly like a small car. Both were launched during a window of optimal outer planet alignments that created a slingshot effect to propel the spacecraft from one planet to another. Despite this, they had to travel at different speeds and on different trajectories. On December 15, 1977, Explorer 1 managed to bypass its twin and has since been our go-to source for data in space-related mysteries. It was the first spacecraft to achieve this when it began its Jovian imaging project in 1978. It was about 265 million kilometers from our planet and sent back a massive amount of images. Explorer 1 completed a remarkable 108-hour stretch starting in January 1979, during which it captured 3,750 photos of Jupiter's rotation to produce a time-lapse film showing 10 rotations of the planet. It traversed the Jovian moon system in February 1979 and, a month later, discovered the faint rings surrounding Jupiter. Explorer 1 also made a fascinating discovery when it found new moons named Thebe and Métis. Precise maneuvers were made to ensure the spacecraft was ready for its flyby of Saturn and to prevent a potential collision with Titan, one of Saturn's moons. Explorer 1 also found 4 other moons during its orbit of Saturn, including Mimas, Enceladus, Tethys, and Dione. Researchers decided to end the Explorer planetary mission after the Saturn mission was completed and sent both Explorer 1 and Explorer 2 out of our solar system at a speed of 325 million miles per year. In January 1990, a new mission officially known as the Explorer Interstellar Mission began. Some of the most notable images and records depicting the solar system and planets were taken by Explorer 1 on February 14, 1990, when it was 6 billion kilometers from the Sun. The images were referred to as the Solar System Family Portrait. Despite the fact that Mercury and Mars were not visible in the photos for various reasons, the spacecraft's cameras were turned off to conserve energy and memory before its journey to interstellar space. In addition to the interstellar mission, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Prior to Explorer 1 surpassing Pioneer 10 on February 17, 1998, Pioneer 10 was the farthest spacecraft. Explorer 1 continued its journey for another 14 years before finally reaching the interstellar environment on August 25, 2012, without any other spacecraft in sight. However, NASA did not publicly announce the achievement until 2013. By November 2018, every spacecraft had officially left the solar system when Explorer 2 crossed the heliopause and entered the interstellar medium. Explorer 1 is believed to be 145 billion miles, or 550 astronomical units, AU, from Earth. It has continued to provide us with essential data that no other space missions have been able to uncover since it entered the unseen region beyond our solar system. The spacecraft has spent most of its 45-year journey in space in good health, but recently experts have noticed some unusual irregularities in its performance. Explorer 1 is currently sending puzzling signals back to Earth, giving the impression that its coordinates are uncertain. There is a concerning twist to the problem. Typically, researchers have pre-programmed Explorer to enter safe mode or sound an alarm if it becomes lost in space. But so far, it has not done so. Its antenna, which sends data back to Earth, appears to be in excellent working order, yet the data it has been transmitting is dubious. The interstellar traveler is operating, taking orders from Earth, and executing them, as well as collecting and sending scientific data. However, readouts from the spacecraft's attitude and control system do not accurately reflect what is happening inside, according to NASA officials. What exactly is happening on board? Every spacecraft headed for interstellar space, including Explorer 1 and 2, has a unique 12-inch diameter gold-plated disc loaded with audio and video messages as a backup in case an alien species finds the spacecraft. The disc includes 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim. They are preserved in 55 different languages so that, if taken over by aliens, they would potentially be able to interpret the signals. The idea that the spacecraft is now under the control of aliens has been quickly dismissed by researchers. Explorer's ability to function heavily relies on the attitude and articulation control system. Firstly, it continually keeps its antenna pointed at Earth so researchers can reliably receive data. It also controls how the spacecraft is oriented. Engineers monitoring the situation now believe the spacecraft is functioning as it should, which only adds to the mystery we currently face. Additionally, none of the safety features designed to protect the spacecraft from danger have been activated, according to Susan Dodd, project manager for Explorer 1. This situation is quite remarkable at this point in the Explorer's journey. The spacecraft is around 45 years old, which is significantly older than what was envisioned in the mission plan. Dodd acknowledges that the spacecraft engineering team will face significant challenges in resolving the issue with Explorer 1 due to the distance between us and the spacecraft. The challenges are largely due to the spacecraft being around 145 billion miles from Earth. This vast distance presents several difficulties that the team must navigate carefully. A rescue operation is nearly impossible given the current technological and logistical limitations. Explorer 1 is far beyond the reach of any spacecraft or recovery project we could feasibly send. The spacecraft's extraordinary journey has taken it to the outer reaches of our solar system and beyond into interstellar space, where it continues to travel further from us each day. Messages sent from Earth at the speed of light take almost 21 hours to reach Explorer 1's current location. Any command or data sent by the engineering team requires a similar amount of time to be received by the spacecraft. This delay poses a significant challenge for real-time problem-solving and troubleshooting. Furthermore, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to arrive. This means that two-way communication between Earth and the spacecraft takes approximately 2 days. This kind of delay makes it extremely difficult to implement quick fixes or iterative troubleshooting techniques that are crucial when dealing with complex technical issues. The engineering team needs to carefully plan and execute each command, anticipating various scenarios and possibilities. Unlike missions closer to Earth, where engineers can quickly send and receive instructions, the lengthy communication delay requires a more strategic and patient approach. Each command must be meticulously crafted to address the identified issues without causing additional problems, given the delayed confirmation time to determine whether the command H add the desired effect. The lengthy communication delay also means the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for errors. This requires thorough testing and validation of commands on Earth before they are transmitted to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The age of the spacecraft's components, although impressive by historical standards, adds another layer of complexity to the problem-solving process. The harsh environment of space also takes a toll on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and tear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains dedicated to resolving the current issues. They are exploring various theories about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is critical given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Explorer 1's design. Like many space missions, Explorer 1 was designed with backup systems to enhance its resilience to failures. The engineering team can switch to these backup systems to restore normal operations if they determine a specific component is malfunctioning. In summary, while the challenges of diagnosing and addressing the issues with Explorer 1 are significant, the engineering team is utilizing their expertise, experience, and the spacecraft's inherent resilience to tackle the problems. Their meticulous and patient approach is essential in handling the significant communication delay and the complexities of working with a spacecraft that is both extremely distant and considerably aged. Despite the odds, their efforts aim to continue Explorer 1's legacy of exploration and scientific discovery far beyond its original mission boundaries. The glitches may be the result of cosmic rays altering the spacecraft's sensitive electrical systems. These high-energy particles, originating from distant supernovae or other cosmic events, travel through space at nearly the speed of light. When they strike Explorer 1, the particles can penetrate its exterior and impact internal electronic components. The longer the spacecraft is in space, the greater the likelihood that cosmic rays will affect its systems. Over time, this phenomenon can lead to intermittent anomalies like those currently found. Additionally, the spacecraft's age is a critical factor in the anomalies. Launched in 1977, Explorer 1 was designed with the best technology available at the time, but it has now been operating for more than 4 decades. The materials and components used in its construction have endured the harsh conditions of space for an extended period. This prolonged exposure can cause degradation, leading to potential malfunctions in the spacecraft systems. While many of its components were built with redundancy to account for possible failures, the cumulative wear and tear over 45 years could result in unexpected issues. Another theory posits that the power source of Explorer 1 is degrading. The spacecraft relies on radioisotope thermoelectric generators, RTGs, for power, which convert the heat released by the decay of radioactive material into electricity. The RTGs have been steadily declining in power output as the radioactive material decays over time. This decrease in power could lead to insufficient energy to operate the spacecraft systems correctly, causing erratic behavior. While the RTGs were designed to last for many years, their power output diminishes gradually, which might explain some of the recent anomalies. Moreover, the vast distance from Earth introduces additional complexities. The further the spacecraft travels, the weaker the signals it transmits back to Earth. These signals are crucial for maintaining communication and controlling the spacecraft. If the signal weakens beyond a certain point, it could result in partial or distorted data being received, complicating the diagnosis of issues. The engineering team on Earth must rely on these signals to understand what is happening with the spacecraft, so any degradation in signal quality can hinder their efforts. The attitude and articulation control system's malfunctions are also critical. This system is responsible for maintaining the spacecraft's orientation and ensuring that its antenna remains pointed toward Earth. Any issues with this system could lead to the antenna drifting out of alignment, weakening the signal further and complicating communication. The control system's accuracy is vital for both data transmission and the execution of commands sent from Earth. Despite these challenges, the engineering team remains optimistic. They are employing various strategies to diagnose and potentially rectify the issues. One approach involves sending commands to switch to backup systems if a specific component is suspected of malfunctioning. The redundancy built into the spacecraft's design allows for such measures, providing a means to bypass faulty systems. This process, however, is not without risks, as switching to backups can sometimes lead to unforeseen complications. The team is also considering the possibility of reprogramming some of the spacecraft systems remotely. Given the delays in communication, this is a complex task, requiring precise planning and execution. Reprogramming could potentially address some of the anomalies by updating the control algorithms or adjusting operational parameters to account for the current state of the spacecraft systems. In their efforts, the team leverages the vast amount of data and experience accumulated from past space missions. Lessons learned from previous missions help inform their approach, providing valuable insights into potential solutions. Collaboration with experts from various fields, including aerospace engineering, astrophysics, and computer science, ensures that a wide range of perspectives and expertise is applied to the problem. In summary, while the situation with Explorer 1 is challenging, it is not without hope. The combination of cosmic rays, the spacecraft's age, power source degradation, and the immense distance from Earth presents significant hurdles. However, the engineering team's expertise, combined with the redundancy built into the spacecraft's design and the lessons learned from past missions, provides a solid foundation for addressing these issues. Their meticulous and patient approach is crucial in navigating the complexities and ensuring that Explorer 1 continues to contribute to our understanding of the universe for as long as possible. The spacecraft's journey, while fraught with challenges, remains a testament to human ingenuity and the spirit of exploration.